Hi, and welcome to our 16-1 lesson on lines. Today we're going to be talking about 3 new vocabulary words that you might remember a little bit from last year. We have parallel, perpendicular, and intersecting. We're going to be using all of these terms in our future geometry units when we talk about polygons, shapes. So it's really helpful to kind of just get an idea of what these words mean so that we can apply them to more complicated figures. So let's start off by talking about parallel. Parallel lines or line segments or rays never touch. Does not matter how far they go on, they are always the same distance apart in every spot that you're looking at. So if you think of the sides of a door frame, or you think of the yellow lines in a street or railroad tracks, those are always going to stay parallel. They're always going to be the same distance, because otherwise if they start getting smaller, then they will eventually touch. Then you have intersecting lines, which do meet at a point. And you can tell that we have an obtuse angle, an obtuse angle, acute angle, and acute angle. That's what's going to keep it different from our perpendicular lines. So intersecting lines, that just means that at some point they touch. And you notice that if you keep making these lines go further, they're going to get further and further apart. They might look at some point like they're parallel, but if you kept them going, you would see that they eventually come together. So those lines are intersecting. Perpendicular lines, or here would be rays because they're part of an angle, they form a 90-degree angle. And that little box that's shown, that's usually a clue to us that the angle is perfectly 90 degrees. Here you have 2 lines that make a right angle, and those lines are perpendicular. So why do we need to know all this stuff? Because when we start getting into our shapes, like 16-3, which is going to talk about our quadrilaterals, we need to make sure that we can classify those figures using these types of lines. So if I take a look at my rectangle, I can tell that rectangles have parallel and perpendicular lines. If you look at the top and bottom, and then the 2 sides, I can tell that these 2 line segments are parallel, and so are these 2 line segments. I can also tell that this line segment is perpendicular to this one and this one, just like this line segment is perpendicular to my top and my bottom. So you can see a rectangle has both types of those lines. Where my triangle, I have sides that intersect at my 3 vertices. And I can tell they're not perpendicular because all of these angles are acute angles. So none of them form a right angle. So they cannot be perpendicular. If I look at my trapezoid, I can see that my top and my bottom are definitely parallel. They follow these lines right on my chart paper. However, my sides are not parallel. Even though they're not touching right now, if I continued to bring these lines up and continued on their path, eventually my fingers are going to touch and it would almost form a triangle. I don't know if you can see those dotted lines I drew here. So even though right now they are not touching, they are still not parallel. And sometimes just dragging your finger along those lines can help show you that. Even if it's not very slanted, even if it's a tiny bit slanted, it means that lines are not parallel, and those can sometimes be tricky. So just to quickly review, our parallel lines are never going to touch, our intersecting lines meet at a point, and our perpendicular lines, or think of them as special intersecting. They're going to meet, but they're going to meet at a right angle, so they're going to form a perfect corner. And I bet you if you look around your house today, you'll be able to find so many examples, especially of parallel and perpendicular. If you think of your walls, of your corners of your house, maybe of some pieces of furniture, you'll be able to find both of those types of lines. So you can comment and let me know what you're finding. Also, I have a bonus question of the day. Hold on 1 second. Here we go. So my question is 97 a prime or composite number? And if you think it's composite, can you give me a multiplication fact to prove it? Remember, that's a pretty high number, so it might be a fact that you're not thinking of. Okay, you can comment somewhere on Google Classroom or a document. Let us know what you think. Have a great day.